Good morning, everyone. I hope you're fine. I hope you still have some power to listen and to think with me about a topic I wanted to share with you that we recently developed. It's about security testing, and how we can make use of models on that. I'm very pleased to talk to you about it. I'm thankful for the invitation to be here. And let's see, maybe I start once again to see my timer running well. Good. Maybe first of all some testing background so that you better understand where I come from. I started in telecommunication, where a lot of conformance and interoperability testing is in use and needs to be developed, and for that we created automated testing support along that TTCN3 testing and test control notation. And once we had test execution kind of cleared up for the automated support, we started to look into how to automate the test design. And some days ago I had here a training on model-based testing, where we started with along the UML testing profile at OMG. And of course, it's not just about developing technologies, but using them in test solutions, test suites, test tools, either directly at the Institute. Fraunhofer is for applied research, where we very often work with the industry to help clear up ICT-based systems by use of testing. And in order to make better support for such developments and testing, we create here and there test tools. And last but not least, we want to spread this knowledge to others by, for example, developing syllabi on how to do test automation at ISTQB, how to make use of this TTCN3 or of model-based testing, which we currently do at the German testing board. Okay, now today I'm going to talk about an ITEA project. ITEA is a research framework in Europe where applied research and development can be done in multinational settings. That project is called Diamonds, and it has been on the development and industrial application of multi-domain security testing techniques. It completed a month ago, okay. And the line along which we developed was based on the thoughts on how to do model-based testing, then how to make it into embedded systems, and lately how to support security, address security by testing. Do you have an idea of security? Maybe we are all geeks here and would say, well, securing the assets of a system would just mean to put up a fortune of IT solutions where we use heavyweight encryption and other security mechanisms. However, indeed, it's very often a multi-level, also social approach to hack into the systems. One of the very best ever described hacks into a system is the HP Gary hack from 2011. Do you know it? Have you heard about it? Have you heard about Anonymous? They hijacked Visa and other major financing systems, and HP Gary is a security company, and they wanted to disclose the knowledge about what Anonymous did with Visa and others. And they announced it before they really disclosed the information, and day after they had an attack of Anonymous themselves. And basically what Anonymous used was first technically to get in the system to have first access to usernames, email addresses, and so on. Then they decrypted it to get the clear text passwords. Then they hijacked the email accounts of HB Gary officials and then used non-super user accounts to get into super user accounts, and finally had full access to the HB Gary systems and made all data available, and even changed and removed data from this security company. Of course, that has been major infringement. It also shows what we basically as IT specialists need to look at. It's not only the technical solutions, but also the processes in social engineering. However, I will only now concentrate on the IT, and I have quite good reasons for that. If you now look into how to better understand, I think the table has been not that well readable. If we now think about how to make it easier to understand, how to model, for example, what has happened there, you can make use of approaches like CHORUS, which is a Norwegian approach, to get a better understanding of security matters, which all start, you don't have a pointer there. This $sign, these are the assets which you start with when thinking about security. So what one has to secure from a system. Then there are basically unwanted incidents on these assets. Yeah? So what shouldn't happen with these assets? These unwanted incidents are the results of certain threat scenarios which are performed by attackers. And these attackers make use of vulnerabilities of the system. And in order to avoid them, once identified vulnerabilities, you make use of treatment scenarios in order to circumvent the threat scenarios which are possible to a system. Yeah? And of course, such models are easy to comprehend, easy to discuss about, easy to put down. Yeah? Starting with the assets and then make clear what a potential attacker can do with the system, where are the vulnerabilities, and how should one treat these vulnerabilities. And as HB Gary hack has been well documented, you can model and see what one can learn out of this attack that HB Gary went through. So, and once you have such a model, you can now make it not only for use of understanding, but also for quantifying the security risk related to a system. And basically, it's then about trying to understand to which consequence potential vulnerability can lead to, and that is just the multiplication of the likelihood and the consequence of getting unintended access to the assets. So, with this CHORUS model, you can assign the probabilities related to the potential threats, and then come up with a risk evaluation scheme, for example, triple value or quadruple value approach, where you make the combination of likelihood and consequences and then assess them to be very low or rather very high, and then you think about the appropriate treatments. Now, what this has to do with testing. First of all, one needs to understand where we are in the status of IT security. It's indeed still the case that the vulnerability disclosures are increasing from year to year. These are numbers from IBM. They are more fine granular, presented by Microsoft, which differentiates or classifies the vulnerabilities and makes clear that operational systems are a lot better off than applications. This is one very important information. And the other one, why I'm also now talking about IT and not social engineering to secure the IT systems, is that there are a lot more low complexity vulnerabilities than high complexity vulnerabilities. HB Gary attack has been a high complexity vulnerability because it was a combination of technical, process and social attacks. The low complexity vulnerabilities are open leaks in just, for example, an IT or a protocol system. So, and that, so to say, gives rise to think more intensively about how to secure the systems also by testing, how to get the check that the treatment scenarios are correctly put forward. And last numbers, also HP supports this understanding that also the split or share of low-level to high-level severity changes over the years. There are still quite a lot of security vulnerabilities which need to be addressed. Okay, now getting to testing. As you know, there is the understanding that testing can be both static and dynamic in the sense of that you either analyze the artifacts of the IT system or you perform it and execute it and see how it behaves. And you can do the static and dynamic analysis either manually or automatically. And depending on which combination you take, you are either in code review, penetration testing, static application security testing, or dynamic application security testing. And out of all the numbers I've shown you, we proposed at this Diamonds project to ITEA in order to work on new methods to improve dynamic testing for security vulnerabilities. We started that project back in October 2010 with 22 partners from 6 countries, including Finland, Norway, France, Austria, Luxembourg, and Germany. And we had a combination of both large and small companies, universities, and research institutes like Fraunhofer, which are there for applied research. And the security testing solutions basically were developed for the case studies which were put forward by the industrial partners, like Thales, like Gemalto, like Ericsson. And the case studies came from different domains like banking, automotive, radio protocols, smart cards, telecommunication, and industrial automation. And if you are one or the other expert in these domains, I think now you stood wondering how I could ever try to come up with a common methodology for security testing solutions in these rather different domains. The pure fact behind it is that at the end, the testing concepts are pretty generic, and once you understand what security testing is about, you can also derive principal approaches which are applicable across the different domains. And professors always need to set some terms. So the understanding of security testing is to check that a system under test meets the specified security objectives. So getting back to cars, what are the assets of the systems you need to secure, and then the security objective is that no threat scenario is possible to these assets. Model-based testing, on the other hand side, is an umbrella of approaches to generate tests from models, to put it straightforward. And model-based security testing is a combination of the both. Right, trying to find appropriate models that help guiding security testing and test generation. So, if you look at model-based testing, then basically you do have on the left lower corner the system under test. That's a target of testing. If you are in a model-driven engineering context, you would rather model the system under test by a set of different models and different abstraction levels, or that doesn't matter. The point is that out of informal requirements at certain stages in the development processes, system models are developed, which are the basis to develop or prototype the system under test. The very same you can do with the test system, with the test device, with the test execution system. Yeah? This is itself, by itself, an IT solution, hardware and or software based. And that can be likewise modeled, and the test model or the test requirements are derived from the original system requirements. Now, if I would like to take this principal approach that I come from the requirements into a test model where I can test on model level, the system model, or generate tests into the test device to check the system under test in its target environment, then with respect to security, I start to think about the security objectives. Then in the test model, like I showed you in Chorus, I identified the security targets or assets and the threat scenarios. And in order to generate tests, I do quite some assumptions, which we call in testing hypotheses, about how the system under test has been developed, what are typically failures, what are the potential issues in the system under test. Then in order to check for security matters, because these are rather about the unknowns, where systematics are not the very best idea to use for testing, I apply randomization to the testing. I come to this later. And of course I need to find appropriate metrics in order to know how good or how complete the tests are that have been generated with respect to the original hypothesis. And then last but not least, I need to run the test and evaluate the tests. Okay. Then thinking a little more about how we can do model-based security testing, it's clear, well, that the real strengths of automated test generation comes together with automated test execution, so that's the basis for everything. And then you do have, remember the CARS model, you do have treatment scenarios to secure your assets. So these are, you could also say, security measures, security mechanisms, which work like any other feature of the system under test. And in order to see if these security measures are correctly designed and realized, you can do functional testing and follow standard model-based testing. Huh? However, in order to get access to this unknown side of the system under test, you better go for some form of randomization. So I try to randomly explore what the system could do in order to see if I can crash it. Any crash is the potential door into the system. Yeah? From theory, it's clear that randomized testing is the one that is potentially able to detect any failure of the system under test. That's a pros. The downside is that it might take you infinitely long. Right? That's why it's always good to think about hypotheses and to use test design methods in order to come up with a finite set of well-designed test samples. Okay? However, in security, it's exactly about the things that the designers have forgotten about to think about, right? So where are the possible entries into the system under test? Well, that's why in security testing, one in particular adds randomized testing. And that's called fuzz testing, fuzzing. Fuzz test cases are used. This has nothing to do with fuzz logic, if you heard about that one. It's just about the randomization of testing. And then as both the functional testing for the security measures and the randomized testing for the unknowns needs to be guided by some understanding where the risks are, you are good off starting with the security risk analysis, as I showed you with Chorus. Okay, now let's get into some more ideas around that or approaches. First of all, risk assessment along ISO standard is about identifying the risk, analyzing it, evaluating it, and treating it. Yeah, that's on the constructive side, what you would do in order to secure your system. The testing part is, you all know this, I guess, that you have your test planning stage, then you design the tests, you implement them, run them, and report the results. Basically, that's it. Now the two can complement each other and help each other. For example, the security risk assessment can help testing for security by helping to find the right tests that need to be used in security testing. Yeah, so I first start with the risk, which tells me where to look at and which parts of the system one should in particular apply testing. And one can get a prioritization and better selection mechanisms for the testing. Or security testing helps risk analysis, because testing is a process to evaluate the system under test. And by executing the system under test, you get a better understanding of the system under test. So it helps to identify potentially new risk factors so that you can iterate on the risk model. Or it helps you to better understand the quantification of the risk. So how likely, for example, is a potential threat scenario. Okay? And getting back to Chorus, what we do is first to find the security tests by help of this risk model, by associating test purposes to the risk factors, and these are these open loggers, which give potential access to the assets. And then we, so to say, design the tests along the threat scenarios of the Chorus model, yeah? By identifying how to stimulate and where to observe the system if the asset has been accessed in an unauthorized manner, for example. The other way around is to take likelihoods to assign to the risk factors and then deriving this table that I showed you before by summing up, by multiplying all the probabilities along the road from the attacker to the asset of the system. And then you can calculate through, get an ordering of the scenarios to which the tests are assigned, and get an understanding how to approach security testing. Now to a case study. Well, in Germany we had two. One of those has been banknote sorting machine from Giesecke and Devrient. They are there, for example, for the National Bank to not only produce our euro, German euros, but also to count different currencies and the banknotes of different currency. And typically, the building itself is highly secured, and then these banknote sorting machines are in highly secured basement, and so on and so forth. And for years, there had been no security issue from IT perspective, because those banknote sorting machines had no access to the external world, to the internet. So you need to think about, like, it was or is a safe room with several door entries, so that already from the process and all the setting around these banknote sorting machines, it was hard to get access, right? The trick would be to just hijack the system, change the counting system, and then take out the money. Okay? That's a core idea. And of course, Giesecke and Devrient want to avoid that. Now that they deploy their banknote sorting machines to quite many places in the world, they want to also ease the maintenance and remote operation of those systems, and started to open interfaces to the internet. Yeah, so they added local area network access, or Bluetooth access, or USB access to those systems. And then the question became, of course, is the banknote sorting machine itself secured from the IT perspective in order to avoid any chance to hijack it. So it was about checking that the access to the functionality, in particular the counting functionality, is restricted, that you cannot hijack the operating system of this network of controllers in the banknote sorting machine, that the admins cannot be hijacked, or the software cannot be manipulated, as well as the configuration. Because these are all potential causes for miscounting or missorting of the machine. And if that would happen, well, it would have been the first step to get access to some money. And what we then basically did is the following, and I guess it's a kind of complicated but main picture for this case study. We started, as I said, with the risk analysis to understand what are the assets in the banknote sorting machine. Then we applied a security test pattern catalog to get the basic patterns how to security test these controllers in the sorting machine. Then we applied test generation to get numerous test cases which penetrate the sorting machine, which we then run via our test execution framework, TTCN3, and receive the results. So I think it's a kind of hard to read, but in one more core idea to this picture is from the chorus analysis into the security test patterns, which then make use of the already existing functional test cases for this banknote sorting machine, because they both check for the security mechanisms as well as for the main usage scenarios for these sorting machines. Then we randomized these test cases by applying a new way of fuzzing the sequences in these test cases. And when executing the test, we even fuzzed the data, so that we had 2 points where we varied the existing test cases. So, and at the end, Giesecke and Devrient came up with chorus risk analysis by models is a good idea. as well as reusing functional testing for the sake of security testing by reusing existing test automation frameworks for doing security testing automatically, and by integrating data fuzzing into these automated test runs. Yeah, and as we also, out of our understanding of how to do fuzzing for test sequences and for test data, we gave the two standardization into DTCN3 so that they see another way of getting good options to certify their products with respect to security. And last but not least, we had to also get an understanding what we managed with this project at the end, so that we develop, maybe this slide is a little too early, STIP stands for Security Test Improvement Profiles, where we did identify a number of key areas where you could improve. For example, one could improve the risk assessment and the test identification, the generation of test models, the generation of test cases, and so on and so forth. And every industry case study had been analyzed with respect to the status before using the diamonds test methods and after. The blue area are the improvements for the Giesecke-Devrient case study, where we in particular improved in fuzzing, test generation, but also tool integration and test identification because of the use of this risk analysis model. Okay, now some more details to fuzzing. First of all, fuzzing is a straight idea. How to inject invalid random inputs to a system under test in order to bring it to the borders or boundaries of its functional or expected behavior, so that one finds potential vulnerabilities to the system. And basically fuzzing is a quite negative test approach because it's about crashing the system, it's about getting a denial of service, security exposures, or performance degradation. And there fuzzing stops, right? If you crash a system, that's only starting of the journey, because then you need to repeat how you made it crashing, and you need to understand what needs to be changed in order to close this vulnerability. The good thing about fuzzing is there are no false positives, because every crash has to be taken seriously. Okay, so, oh, sorry, I had another, I wanted to get this figure here, which depicts a little bit what fuzzing is about. So you see the green field is the specified functionality, the red field is all what is forbidden to system under test. And fuzzing is exactly at the boundaries of the system, which is already invalid, but which, so to say, is still accepted by the system, and where it tries to act and do something about it, in order to make it a little easier to understand. The red area is, of course, infinite in size. The green is finite, and the fuzzing needs to find good ways of elaborating the border of the system. And then model-based fuzzing is really about not just randomly explore the boundaries of the system, but as you need to find good finite sets of tests, to use some knowledge about the system, of its structure, of its behavior, of the logical dependencies. And with the behavior fuzzing, as I tried to say already, we started with the existing functional test cases, which give us the basic interaction with the system under test. We identify blocks of logical dependencies, and then we apply fuzz operators to these sequences so that, in simple terms, you rearrange the interactions, you add, remove, change interactions to the system, and get invalid sequences which you give to the system on the test. Yeah? And while you, say, have 1,000 functional test cases for systems like these banknote sorting machines, you typically have 100,000 and more fast tests, because there we really need to invoke a lot of test cases to find the potential vulnerabilities. And because of these numbers, you have also no chance to do it without any test automation. Okay. Two more things I wanted to tell you. One is about traceability, right? So I put now up a picture of, we do risk analysis by modeling, then we identify the main test scenarios, main test objectives, generate tests, and then randomize even the tests and run them. At the end, you need to understand what happened along test execution and test evaluation, and you need to be able to give the ready to deploy or not. Right? And for that, one typically needs tracing between all the artifacts from the risk model to the, say, system models, test cases for security testing, and back to the original security requirements. So what we were thinking also about was how to enable tracing framework where different test tools, different modeling tools can be integrated as out of the various domains in use in diamonds. It was clear that there are not the single one tool for risk modeling, not the single one for system modeling and test generation. So what we made use of was Eclipse, a tool integration framework, which also offers tracing basic integration framework, CREMA, and then we put up one instantiation of this traceability framework by taking the CORAS tool from Norway, adding ProR for the test requirements, the UML2 Papyrus for the modeling of the system components and test sequences, which then turn into the test cases in TTCN3. So, and the basic idea is, starting with risk assessment, you trace into the test identification, which then turns into the test specifications, which become TTCN3 test cases, and at the end you relate back the results of the test execution to the original assets which you need to secure. I need to hurry up a little. So this platform then at the end gives you an integrated view of everything, where you can, let's say, see the traces, even change them, explore them, select them. And here you see an example between CORAS and the ProR. And at the end, you do have the different traces from the test cases into the assets and potential threat scenarios which relate to the test cases, and then you get the numbers, how many test cases there have been, how many have been executed with which results, which then show you where to secure the assets even further. So last but not least, to the security testing improvement profiles. It was about getting an idea how these different case studies from the different domains compare, and also what one can use outside the project in order to improve security testing processes. And related to TMMI, we started to identify key areas and different levels, so that every industrial partner assessed where they have been before and after diamonds. So that, for example, we ask about how did you do risk assessment, how did you identify security tests, did you automate test models, did you generate the test, did you apply fast approaches, do you use automated test execution, and so on and so forth. And for each of these key areas, we added levels where, for example, for security test generation, you could use manual test design, supported test design, dynamic test design, and last but not least, model-based automated test design. And in result thereof, we got a table where each partner assessed it. You don't have to read this up. There are figures which I have shown you before. The interesting ones are the blue areas because they have shown the real improvements. We also have had an example which is a strong starting point and just little increase because they were already advanced, or one other example where they didn't yet do a lot in automated testing and automated test design, where they applied the first steps to test automation. And that brought us into, at the end, improving in different areas in risk assessment, tool integration, test generation, and all these results from Giesecke and Devry and Gemalto, Mezzo, Thales, and others. They are all described if you are interested in experience reports, which are available either at a report from ETSI or at the Diamonds website. And you can also have a look at the STIP evaluation process if you like to understand where your company stands with respect to security testing. Okay, that's basically already from my side. Final slide on where we put our new findings and understandings to standardization. We give it on the one hand side to ETSI, where there's quite some work these days on model-based testing and security testing, so where we improve the terminology also with respect to security aspects. We added the fuzzing approach to TDCN3, and we supported some test suites for IMS and IMT in order to help improving the test suites there. Okay, that's a team. Of course, it was not a small project running for 2.5 years, 6 countries. That's why there have been quite some results, which you all find on the Diamonds website if you're interested. If you want to read up more on model-based behavioral fuzzing, you can find it via the Focus website. We even created an open source library for the fuzz operators. Whoever had looked already into fuzz testing should know that there are different fuzz testing tools, but they are all standalone tools. With this library, you are able to hook fuzzing into your existing test environment. As we did it with TDCN3 and the TD Workbench, we did it for Daniel Consulting into their Do Atoms test environment. Mezzo implemented it in their test environment as well. So the idea is to have basic fuzz operators which you can use to randomize test data and test behavior. And then if you want to get an understanding of the security testing profile, you can have a look at the security testing improvement profile STIP and how it has been used in the different case studies. That's it from my side. Thank you very much for your attention, and I'm open for your questions. So, do you have questions? If not, I guess it's ready for... Oh, there has been one? No. Okay. So then I guess.
Wait.
Oh, sure.
But I'll talk about it. One of the issues with model-based testing is the level of expertise that it takes to work these things.
John, I hardly get the question.
Okay. One of the problems with model-based testing is the levels of expertise necessary to do it. Can you comment on how that team was in terms of their knowledge of basic modeling concepts?
The question was, what are the issues in model-based testing in related to general modeling?
Basically, yes.
Okay, it only comes here partially. Well, it is about identifying the necessary elements that you need, I'd say, to create the test solution, right? You need to say what are the required and the forbidden scenarios in the system. You need to say how you evaluate observations from the system on the test. You need to talk about the test configuration, the different test variants you use when evaluating the system on the test. So these are all a concept dedicated to the testing domain only. And that's why with the testing profile that we put forward in OMG, you can come up with so-called test models which are dedicated for the tester's perspective on a system under test. And these test models then help you to generate the tests also in an automated manner, and if possible to run them automatically as well. Also, those not necessarily need to be combined, while I would always recommend to do both automatic test design and automated test execution. So, of course, you could, for modeling test solutions, you could use UML as such. However, you would always need to think about what is the test case, what is the test component, what is the test configuration, right? And if you would do it first time, or if 2-3 people would do it, they would come up with different solutions for that. However, as there is already the UML testing profile, you may have a look at that one and make use of it. So then, thank you very much again, and well, I'll be around.
Thank you to Professor Dr. Ina Schiefer-Decker for her presentation this morning, and with that, we've come to the end part of the presentations. The early part of the morning, and later on I think you'll be going for your tracks. Right now, ladies and gentlemen, I would like to, as we won't be gathering again together today, and all of you will be going to separate tracks, and this is the only time we'll see everyone, it is my pleasure to now invite Mike Cornelius. He's the director of MSTV, to deliver the closing remarks.
Good morning, and thank you very much for coming. I know it's been a bit of a challenge this year with the rain and the traffic, but I think we've had a good crowd, and I hope you all agree it's been worthwhile coming. This year's been a milestone year for MSTV, and actually for the industry here in Malaysia. This is our first SoftTech Asia, and we've welcomed not only speakers from all over the world, but users and testers from all over the world, or all over the region at least, to come to this conference. We've tried some new things. We've had great user stories from the likes of Jeff at Maybank. We've had the CIO forum, which maybe people don't understand the importance of that or see the immediate importance of that, but what it's saying to us, at least, is that testing and quality are now visible at the highest levels in companies, which is really, really important. As you probably, if you've been here before, and in any case you'll see that we've had a big crowd this year, the biggest ever. And we're very, very pleased to have you all here. Obviously with more people, the logistics get a little bit more difficult, but I hope you've all had a good time here. And I think we have to applaud the hotel for actually making plenty of food and actually making getting in, getting out, and all the other things actually painless for us. And I hope the people who've come in from overseas have really enjoyed their visit here, even if it's for the first time to Malaysia. And it doesn't always rain. We've had an action-packed schedule. It's been very, very busy, and I know we've got several more tracks today. We've had a wide range of very, very interesting topics, from what can only be described as a truly impressive list of speakers from all over the world. Now, one of the privileges as the director of MSTB is I get to attend a lot of these events and meet a lot of people in the industry. And I'm always humbled by the depth of knowledge and experience and just the ability to understand the issues and complexities of testing that our guests show. Some of our speakers have been here before, old friends such as Ina and Chris and whatever. And we've also had a whole range of brand new speakers, new friends, such as Laura and Professor Klaus. I hope you've had a good time, and I hope you've learned many new things and new ways of looking at maybe old issues and problems. Now, as somebody at the other end of their career to many of you, I've managed or been responsible for hundreds and hundreds of projects over my career. And I would have said, without going into technicalities of it, probably very few people can teach me very much about project management. How dumb can I be? Yesterday I was sitting down in a lecture just listening to, I think, Laura at the back there. And she just made a little throwaway remark, and I thought, my God, if only I'd known that 20 years ago. So thank you, Laura. Where have you been all my life? Please enjoy the rest of the day, and we hope to see you next year at SoftTech 2014. Thank you. It appears I have one task.
Thank you, Mike. Of course, we have to grab him to do the lucky draw before you break out for your tea break. But before that, I need to talk to you about the feedback form. When you fill it up, and we hope that you will fill it up with some constructive comments, please hand it into the registration counter anytime after 4 p.m. today to redeem your backpack. So we would love to hear from you, what you think, and anytime after 4 p.m. Send it in to the registration counter to get your backpack. All right, so this is the last lot of the lucky draw prizes. So Mike Cornelius, Director of MSTB, will be doing the draw, and for the first one, it's for a hamper. We have a hamper, 3 SoftTech tickets, and an iPad at the end. Okay, Mike's going to read it.
I'm going to read it, hopefully. W.M. Azif from the MOE.
You might have to read it again. Asif. From MOE. He wins one hamper.
So this is
now it's for the SoftTech tickets. The next 3 will be for SoftTech 2014 tickets.
So Ho Wing Teng.
Okay, doesn't say where this person is from. Ho Wing Teng.
Nur Deniza Abdul Rahman.
Nurhaniza Abdul Rahman. That's right. And the third one.
Sorry, the light is very poor up here. And somebody writes even worse than I do. Yeah, Wong Suk Yin from Comtel Communications.
Okay, those are the 3 winners for the SoftTech 2014 tickets. And now we go to the last prize, that is the iPad Mini. And the iPad Mini goes to, that's the last prize of the day for the lucky draw.
Michael Cornelius. Oh! Azia Fatila Binti Mia. Okay. SPRM. Congratulations. As a final comment, can I please ask you to show your appreciation both to our host, who has been delightful as usual, to the many people around the room who've helped us make this happen, and of course, last but not least, to all of our wonderful speakers. Thank you.
Thank you, Mike. And for the winners, you can pick your prizes up after 4 o'clock at the counter as well. So now we have a break, and then we go to your respective tracks. And thank you for being here and for sharing this conference with us. And we really do hope to see you again next year. So have a good rest of the day.